3 days. That's where we left this last video. And I said it took 3 days for the scientific community to come around and say, absolutely go for it, do what you need to do. Everything here is great. Everything here is safe. Not a problem at all. Right? What I like about this cartoon, you got a couple of people here, this guy holding some carrots saying, hey, it's perfectly safe. And this guy holding a flask with some steam coming off of it. It says, what have we done? And then we have the Godzilla carrot back here in the back that's getting ready to eat everybody. Okay? Was this a possibility? How far could we actually push this genetic modification? Well, after the 3 days were over, let's take a look at genetic modification after that point. 1980. Genetically altered life forms can be patented. That means if I go into my lab and I create this bacteria that does a certain job that no one else has created before, I can patent that. No one else has rights to use that or to mimic it or to copy it. ExxonMobil created an oil-eating bacteria. I mean, how great could this be, right? ExxonMobil, an oil company, if they have an oil spill, well, we'll spread bacteria all over it and it could eat and decompose the oil and help clean it up. That happened in 1980. 1982, the U.S. FDA, Food and Drug Administration, approved Humulin, like insulin. But this was insulin that was made by bacteria. The company that produced this, that was Gene Tech. All right? Gene Tech, guess what? That was Cohen's business that he started here. Cohen, this guy, right there, Cohen, started his own business after the biotech surge, and this business ended up producing Humulin, which was approved by the FDA in 1982. This was a way that we could get insulin much quicker, much faster. We didn't have to synthetically make it. The bacteria made it for us. 1986, test on the engineered tobacco was performed. 1987, field test of genetically engineered crops, which mainly included tobacco and tomatoes, were first performed. 1992, the FDA states GE foods are not inherently dangerous. 12 years, many studies, many tests, many versions of genetic engineering started to pop out all over the place. And in 1992, 12 years after all of this process got started, the FDA finally stated it's not inherently dangerous. Here's another timeline. This timeline predates 1973. This is where we started talking about the artificially selected crops. Boyer and Cohen, 73, finally incorporate genetic engineering to the world. 1 year later, a couple of guys created the first genetically engineered animal. Guess what, folks? Animals can be tailored at this point, if you've ever watched that South Park episode, where we can grow human organs on rats at this point. Yes, sir, we can. That's genetic engineering. Maybe not the one that's focused in on the South Park episode, but we can do it. 1975, well, we get some guidelines. That moratorium released some guidelines that we needed to follow for future genetic engineering experiments and modifications. 1980, Supreme Court comes around and says, yes, you can patent it. And this is when ExxonMobil got into the picture. 2 years later, FDA approves Humulin, first pharmaceutical manufacturer. 1992, Flavor Saver tomatoes finally come out onto the consumer market, approved by the U.S. Department of Agriculture. These tomatoes, they would not turn. They wouldn't get old and mushy within a matter of a couple of days. They lasted a little bit longer. A couple of years after that, U.S. EPA approves the first insecticide-producing crop. That's right. This crop, well, pests were a problem, especially in the corn industry. How can we get rid of the pest? Hey, genetic engineering could do this for you. Are you tired of buying pesticides? Are you tired of spraying pesticides all over your fields? That costs a lot of money. It costs a lot of man hours. Okay, there's some effort that has to go into that. And more than that, look what you're doing to the environment. You're spreading pesticide everywhere in the field and everywhere else around it. So, what if genetic engineering could tell you that this corn product we could modify and we could allow the corn to grow its own insecticide on the inside? So, if a little bitty tiny bug comes around on this plant and it begins to bite into the leaf, then that bug will die. Ah, are you kidding? Farmers love this. Right? All of a sudden, I could grow corn and I wouldn't have to worry about pesticiding it because it had its own built-in pesticide. So this pesticide was poisonous to the insects, but you ate it too. What did it do to you? Well, nothing, because those pesticides do not have an affinity to my metabolism or my organs. It did with the insects, but not with me. 1 year later, if you could do it with insecticides, you could do it with herbicides. And this is our first herbicide-resistant crop. Now, many people don't understand the difference here. Insecticide is killing bugs. Herbicides are killing weeds. All right? Weeds can overtake a garden. Weeds can overtake a crop. You can imagine if you had a whole field of corn and weeds took it over. You don't want that. It is competing with the crop that you're trying to grow. You got to get rid of them. So you could go out and hand pick them. That would take you days and days and days every week in order to do that. The only thing that you'd be doing was picking weeds. Well, the next thing, you use an herbicide. The herbicide will target those weeds and kill them out. It won't target things like corn, but it would target all of the weeds that you want to get rid of. Well, if we can make an insecticide product, we could make an herbicide product. Herbicide resistant, at least. Year 2000, golden rice. Look, there it is, engineered to have a higher level of vitamin A. And this was intentionally done because of the vitamin A deficiency problem that we had. And in 2009, pharmaceutical company produces a GE animal to be approved by the U.S. FDA. Again, work is still done in this field. They're pushing the buttons as far as they can push them. They're getting creative. New things are coming out. And the problem is, where does it stop? How much leeway do we give these researchers? How much leeway do we give them to go in and make these decisions and play with the genetic code of all of these organisms and splice them and put them together and create new products that they can grow into a field or grow into an animal, and then allow me to eat those types of experimentations? That is, again, where the hot topic of genetic modification begins. Is it simply just creating an insecticide-producing crop because we're looking out for the farmers? Or is there another intention? I mean, imagine it. What if you were one of those companies that made the insecticides? And all of a sudden you were faced with this idea that produce could be grown that have built-in insecticides. Your company's no longer needed. Your company will go out of business. You think they went for that? Herbicides were the same way. What? You're telling me that you're going to allow genetic engineers to go through and create these products, and that's going to put me and my business, multi-million-dollar company, employs hundreds of people maybe, out of work? Because we make those herbicides. And now you're going to tell me that they're no longer needed because all of this stuff is going to produce their own? You can imagine some of the backlash that was getting created. Flavor Saver tomatoes. You're telling me that you've made a tomato that can last longer in the grocery store, and when people buy it, well, it can last on their countertop a little bit longer? But I'm a tomato farmer. I mean, I make my money by selling tomatoes. And if I'm going to grow something that's going to last longer in the grocery store, then that means you don't need to order from me as much, right? And if I'm selling something that's going to last a little bit longer on your kitchen countertop, that means that consumers are not going to the grocery store to buy that tomato as often, which means that that grocery store, again, is not going to order from me, the farmer, as often. Oh, we're starting to get a problem here. Great intentions, but did we really think about how it affected everybody else? That's the thing. So, by demand, we begin to get regulations that come into the genetic engineering world. These regulations are going to target a number of different things. The regulations are going to start looking at this product or these products, and they're going to ensure that a certain number of standards are going to be followed. First, the company is going to have to do their own research. The company can't just create something today and release it on the market tomorrow. They're going to have to go through some studies. They're going to have to go through some tests. They're going to have to ensure that this product is comparable to the original product with the enhancement or the modification that they've done. This is what we would call regulated field trials. So once we, let's say, make this tomato, then we're going to take this tomato out into the field and we're going to grow it in batches, and we're going to see how it behaves, and we're going to see what it infects and what it doesn't infect or affect, right? We're also going to have internal reviews of that material. The company that's doing this, they're going to have to kind of consistently come back with data. They're going to have to change and modify based on what they are seeing that's happening out there when it grows, when it's harvested, how things are responding to it. Nutrient panels. All of my carbohydrates, all of my sugars, all of my lipids and fats, all of my amino acids and my proteins, all of that's going to have to be determined, and we're going to have to compare it. So therefore, if I have a corn cob that has been genetically modified, I need to compare that to a non-genetically modified corn cob before it happened, and I need to ensure that no major differences are there between the two. I can boost up certain nutrients, but they cannot be completely different, meaning my genetically modified one cannot be depleted of multiple nutrients. We want to make sure the integrity of that food product still exists. We're going to have to go through gene studies. Gene studies are basically looking at the DNA code, figuring out what's going on, why is it happening. We'll report that gene splicing that we're doing to make sure this is safe and legal. Environmental and ecological assessments in the lab and in the field. So again, when I plant that produce, like that tomato plant, I'm going to have to start taking a look at how things interact with it. The dirt or the soil, the air, all of the pests that are around it, other things that are growing nearby. Is it affecting anything at all? One of the bigger problems are allergen tests. If we create these new things, then what is really new about it? And is that piece that's new about it going to create an allergy that we did not see coming? So for instance, let's say that I had an allergic reaction to honey, and that honey, for some reason, had an effect on me. And I go through and I eat this spinach leaf, and this spinach leaf was spliced with something that was found in the bee, and that bee mechanism is what produced the honey, and now that gene is inside of that spinach. So when I eat that spinach, because it came from that bee that made that honey with the same mechanism, am I going to have an allergic reaction to that and not expect it, and eat so much of it, like a strawberry spinach salad, that I'm going to find myself in the hospital? Allergen tests are very important. And finally, substantial equivalence test. That is where we say this spinach leaf is going to be the same as a spinach leaf that is not genetically modified. So 3 companies, 3 organizations, I should say, are going to step into the picture. And these organizations all have a different role. The USDA, the FDA, and the EPA all play a significant role in genetic modification. The USDA, which stands for the United States Department of Agriculture, will look at the genetically modified organism and say, is it safe to plant it, and is it safe to grow it? Notice it doesn't say, is it safe to eat? That is not the agricultural's role. Planting it, growing it, that's all that they focus on. The FDA's role, is it safe to eat it? That is the role that they play. And finally, the EPA will look at environmental concerns. How is it affecting the soil? How is it affecting the wildlife that's around it? How is it affecting insects or the birds that are basically coming into the field? Is it herbicide or pesticide producing? If so, what is it? How is it behaving? How is it affecting other things? All of this plays a role in the environmental safety. So 3 organizations funded by your tax dollars, all 3 have a completely different role to play. And as you can imagine with any government organization, well, are they going to do their job exceptionally well? I mean, working with 1 is bad enough, but now you've got to work with 3? And quite often, they don't talk to each other? Oh, I see the problems now. So in the next video, we'll pick up from here. We'll look closer on the USDA, FDA, and EPA's role in GM, and talk a little bit more detail about the wording that they have decided to use for themselves. And as you can imagine, there's probably something up my sleeve in saying it that way. So come back, don't let me keep you in suspense, and we'll talk about these 3 government agencies that you fund. Congratulations, write out your check.